All right, why don't we get started? And we'll start off a little bit slow just so that as people trickle in, we don't cover too much content. Thanks again for everyone joining. I'm Anthony Placeris. I'm an architect here at CDW, and I just focus on AI infrastructure, high performance computing, do quite a bit of work with the financial services industry. And we also have James McCarrick here from VAST, who's a systems engineer, who's going to be talking about their platform. Today, what we really want to do is have a focused conversation on a specific industry vertical within financial services and talk about some of the challenges that trading firms or hedge funds, capital markets customers out there face today in dealing with data to find alpha. So I'll just kick this off. This is going to be somewhat podcast style, and I figured to just wrap some context around why we are bringing Vast here to talk to you guys today, why we think they're a relevant player and an important technology, player in this market. So a couple of reasons. So let's just talk about some of the trends that I'm seeing in the market and what CDW is seeing in general. And just in case some of the customers here on the line aren't aware of this, CDW has a practice that's just focused on the FSI vertical. So we try to focus explicitly on your needs. And again, let's just kind of break down some of the trends I'm seeing in the market. What's changing with the landscape, both technical and business related. One of the big things I feel is important to acknowledge is that in order to identify signals in the market, there's been like this growth in alternative and unstructured data for seeking alpha. So this is having somewhat of a profound impact on the way our quant finance and hedge fund customers are approaching, their decision making and some of their modeling techniques. This is, again, focused maybe just on front office operations for a second here. As part of this, right, there's somewhat of like a algorithm arms race. And part of that is more sophisticated models are helping market makers, hedge funds, and both buy side, sell side figure out how to do, to extract signals quicker, right? And what that means is that these models are becoming more sophisticated, and it's requiring potentially higher precision simulations, for example, for option pricing or risk management. What this is really changing is maybe the need or the demand for more parallel type processing. This kind of move from just high throughput calculations into HPC-like parallel processing. And we're also seeing this introduction of GPU accelerated compute into the mix and helping with a lot of this analysis. But this is also having an impact now on how you actually feed data into that instrument. So, we also see that there's this, because of the alternative unstructured data sources now that contribute to, important signals in the market, we have now a need to store all of this data, bring it together and converge it in, structured and unstructured data into one type of lakehouse. And then, while I've kind of called out some trends in the front office, we also see this proliferation of use cases for AI, both generative AI and natural language processing and other machine learning techniques, not just for front office, but for middle and back office operations. So ever since ChatGPT came about, we find that a lot of the companies we're talking to are not only trying to, discover new ways to extract insight from market data, but they're also trying to make their coworkers more productive, or they're trying to attract new machine learning architects and engineers with AI assistants that can help them with their code output. So there's kind of these other back-end productivity suites of applications that are changing the demand for infrastructure in the technology landscape. But there's challenges that come along with all these trends. And James might be able to comment on some from his perspective too, but among one of the top challenges here is just data management and the integration of all this new structured and unstructured data. So we have an explosion of data, not the least of which is coming from like social media and news feeds and things like that. But we also have a growing interest and a booming market for crypto. And there's so many exchanges now for crypto. It's no longer just like a retail fad to invest in crypto. We see a lot of institutional interest. So it wasn't enough just to kind of deal with the explosion of data that comes from unstructured sources like Twitter or now X or some of these other news feeds. But now we have to deal with the explosion of data coming from these other exchanges and these other markets. I've mentioned this earlier. It's not simple to keep up with the algo arms race, right? And in order to kind of be able to beat the market, you kind of have to be very innovative, and you have to take new approaches or employ more sophisticated, harder to explain models that give you kind of an edge on the market. At the same time, you're dealing with changes to the regulatory landscape. There's increased scrutiny, and I think that a big challenge with all of this is, in order to balance everything, there's this constant push and constant need to keep up with the technology landscape at hand, right? Because it's it's one thing typically, you're the firms that have the folks with the bright minds that can sift through all the data or use a compute medium to sift through all that data and create a model by which you can make a decision or an investment decision. But in order to continuously stay one step ahead, there's always progress in the technology front. So just keeping up is a challenge in and of itself. And then we're just seeing now, a challenge with customers finding, competing for a small pool of very highly talented individuals. So keeping up with talent is also something that is not easy. And what I was saying earlier is, one thing is to go out to the market to look for folks who have the skill set to build models that can help you find alpha. But another skill set, again, when I was calling out the changes to the technology landscape, is the more my technical problem evolves, maybe the higher skill my technology operations needs to evolve. And so we see this growing demand or interest for HPC-like engineers, and even that becomes somewhat of an obstacle. So a lot of this I'm just calling out as big precipitating factors for why we think VAST comes in and they play like a really valuable role here is that, as we shift into kind of a much more complex data landscape and infrastructure landscape to support this, it shouldn't have to be so difficult, right? There can be simple platforms out there that bridge that gap between easy to use, familiar type technology platforms, but also bring a ton of great new features and performance improvements, from the status quo. So we just want to give you a little bit of insight on why we're seeing VAST grow in popularity with our quant, our trading firms, our capital markets and hedge fund customers. And I'll kind of hand over to James to talk a little bit more about what he's seeing, or if he wants to chime in on some other challenges he runs into.
I think everything you're laying out is very correct. Race for alpha combined with protecting your data, and then I think what we're seeing is some of these places are finding that their heavily curated data is incredibly valuable, even marketable. And how do you create a way for outside sources to consume it, right? Adds to the whole nother layer of how you can keep the data secure and find other ways to capitalize off of it. So yes to everything you've said here. It's exactly what we're seeing. I can take over if that's all right, and I will.
Yeah, why don't you go ahead and change the slides? That way it's a little bit easier.
Sure. Great. Does this work?
Yeah.
Perfect.
Looks good.
So I've been at VAST since 2019. One of the first people to come on once VAST actually had a product, and it's been quite a ride. And so I've been kind of lived this, breaking into this space. So VAST is a significant presence in the quant space today, and there's a lot of reasons, but here's some of the driving factors. This is one of our largest customers at both their current scale and their projected scale. There's a lot of data growth. You can see the VIX here, volatility index has taken a huge spike after COVID and continues to be that. And volatility drives data. People are finding that going back and being able to mine 40 years of stock market data is becoming increasingly valuable, to where if I can compound my information from what I'm grabbing today versus what's happened historically, I can make better decisions about the future. And as you mentioned earlier, crypto has added another layer of data growth. So we have, exponential growth in this unstructured, semi-structured data. How do we make it accessible? How do we compute against it? This is where VAST has come in. VAST has we have a VAST data platform. The place where we enter the market is really the VAST data store. So starting with the data store, what is the data store? Well, at the core, VAST is a massively parallel file system object store built with the idea of segregating out compute from the capacity. So you're understanding your data set being fundamentally at a storage layer, but the work against the data set being completely abstracted out in stateless computers. And these containers, now that they're disaggregated, allows us to scale them independently. I can add more capacity to meet my increasing storage demand. And as my demand and as the performance demand on there comes, I can then scale compute completely independently. And this is how VAST has been able to build systems that scale into the hundreds of petabytes into a single cluster, driving terabytes a second of throughput. We do it with the idea that we must abstract these two elements to accomplish this task. A key part here is VAST serves out file and object. Now, for the more traditional spaces that where we go after like parallel file systems like GPFS or Lustre, we look at tackling that with something like NFS v3 or v4. We do have full RDMA support on that fabric. Object, we're seeing become an increasing demand as well. Now, what we're showing here is this protocol layer where NFS, SMB, and S3 all sit as what we call first-class citizens. These are all protocols developed in-house because we had to write these ourselves to make sure they scaled the way we wanted them to. So they can all demand full performance of the cluster, and they can all touch the same data. So everything we write down, we call an element. So whether you write it in over NFS, SMB, or S3, it is all functionally the same data set with this kind of superset wrapper to address all the different protocols. So the traditional systems that can write in over NFS, there's becoming this increasing demand that we're seeing across customers in this space to then build new types of querying that data over object. And because VAST does not delineate between file and object, anything written over NFS can be read out over S3 in real time. There's no layers in between. There's no proxies. Again, because both drive the full performance, this is all seamless. So you can imagine having some more traditional stacks built on file and some of the newer work being done built on object, and having that ability to instantly collaborate these two without having siloed infrastructure is a key part to what's kind of accelerating the growth in this market with VAST.
Yeah, out of curiosity, I know you'll probably touch on it at some point, but like kind of just referencing back one of my earlier notes about like this this movement towards or the experimentation with GPU accelerated compute. Any way you can kind of comment on like how this is having a profound impact on like traditional file platforms and how they can't keep up, and what is VAST doing differently?
Sure. So we look to attack the parallel file system space and deliver functionally a massively parallel system while keeping kind of the ease of use of universal protocols, right? If you go into the parallel file system space, you deal with a lot of custom things, custom drivers, custom code, custom software to manage, and it's a very rigid environment. Accessing the data outside of them becomes very costly, hard to manage. But that was traditionally seen as the way to get the parallelism you want. The new way with what GPU is doing, the sheer amount of throughput plus randomness of the data that things like AI are generating means that not only do we need all flash, we need to deal with stacks that are built for that type of parallelism. So VAST implements things like RDMA. We have like full SuperPod certification with NVIDIA, and we can drive significant performance even over the NFS stack to saturating to doing hundreds of gigs a second, which I'll show in a little bit, all over a single easy-to-use simple mount point. The goal being simplicity on that platform. As people are rolling out, millions and millions of GPU, we don't want them to be spending time managing the storage. So simplicity and simplicity in getting the performance you need immediately becomes a key factor in why people go with VAST.
Yeah. Yeah, maybe just to comment on this. This is a big game changer too, because again, the mechanism by which you present that out to the end user still looks and feels a lot like a traditional NAS, but under the hood, it's performing much better. And I think why this is important is, if your firm is diving into that realm of continuously growing your compute estate for either for back testing, for research, for pricing calculations, risk calculations, things like that. The more parallel it gets, sometimes what we'd get into this scenario is that you couldn't keep up with the demand from the compute side on the storage end of it. And so there's this interest to evaluate parallel file system type technologies. But the traditional parallel file systems then come with another set of complexity, right? And so now you're having to manage things like proprietary POSIX clients and other things that maybe the traditional IT team isn't comfortable with, right? So again, I think it's important just to note that what VAST is doing is essentially helping bring that level of performance to keep up with the pace of the computational expansion without overcomplicating things for your storage engineering team.
I 100% agree. You can see here that VAST has basically broken the traditional trade-offs of NFS. NFS has always been seen as a simple, very easy to use universal protocol, but fundamentally slow. There's some work under the covers with a technology called NConnect that's a newer Linux kernels, and VAST basically can take that and supercharge it. And again, because we support things like an RDMA fabric, you can actually do NFS over RDMA. This is how we have the SuperPod certification through NVIDIA. Everything with them is either over Ethernet or InfiniBand because we're flexible and we can support both. We can do this where if you had, a DGX with 8 200 gig NICs over a single NFS mount point, get full line rate saturation across all of those NICs. And again, this is minutes to set up, right? You set it up and then you don't think about it. So incredibly flexible, incredibly fast, and incredibly easy to use. One other nice point to this disaggregated approach, where again, every single one of these compute nodes can read and write anywhere on the storage fabric. This means that when a user comes in to do a read or write, that CPU that's doing that processing doesn't need to tell all the other compute what it's doing. There's none of what we call east-west traffic. They can write directly down to the storage fabric because both the metadata and the data sit at that SSD layer. So we get a couple interesting things here. One, the easy one is availability. If I have, 100 compute nodes and 99 were to fail, because every compute node can write anywhere in this fabric, I'm still online. I'm running at the performance of one of these compute nodes, but the availability, the cluster is still 100% online. The next part is isolation. We know that many firms have many desks. They have different I/O patterns. They have different access into the storage. VAST was built to be incredibly transactional, doing millions of IOPS a second, and very, very large throughput all at the same time. So we don't care if you're storing millions or billions of files or objects, or if you're doing compressed objects and you want to drive terabytes a second out of it. This all works under the single platform for VAST. Now, what this pooling allows you to do is give these kind of nice hardware boundaries where you can imagine desk one looking to run these very large distributed queries. They can saturate their compute nodes, and desk two is completely unaware of what's happening. Again, because the compute nodes are separate and they can perform their I/O independently, you can now deliver different qualities of service to different trading groups and either create one big pool or give explicit isolation to different teams to make sure that no one's complaining when the other one runs some big batch job, for example.
Yeah. So let me get this right. So like essentially, for a larger company, or maybe not, it doesn't have to be massive, but for a company that has to serve out the infrastructure in somewhat of a multi-tenant fashion for their end user groups, you're virtually creating or physically creating a no noisy neighbor type of experience is kind of part of that.
100%. And that
Okay.
also applies to, even if it's the same trading team, you can have very interactive use cases where users want to crawl millions of files, and you have this 10,000 core compute farm that wants to just saturate us with throughput. You can imagine
Mhm.
peeling off some compute nodes, and now when that big batch job runs, that's driving hundreds of gigs a second out of VAST, that person who's crawling a million or a billion files is not impacted and completely unaware.
Awesome.
VAST has then been able to stretch this namespace. So today we have cloud instances, we have replication, and we've just released our release of what we call global namespace. So now we can talk about the idea of having a fully consistent namespace drawn out and stretched at distance to where data access can be consistent across all sites. And this where we feel, you can imagine if you're doing a big source of collection in site one, maybe you have like a market feed coming in. Site two can make queries against the data on their local cluster in real time. And we feel that being able to stretch this at distance allows us to, put the data, allow you to collect the data at a source, but then make it available globally, especially if you have to stretch your compute across distance, put it at the edge, and even in the cloud. So this just because VAST at the end of the day is a bunch of software, we are building. We have AWS and GCP, I believe, is imminent, and then Azure will be later this year.
Yeah, I think this is a kind of a very important structural feature that most of the customers I talk to really need. That a need for a global namespace, is pretty important. Being able to kind of have multi-regional capability or multi-domain type of feature stack is important. And part of that comes down to like how the modern data platform wants to pull from data sources, right? And so if you look at the way maybe a data scientist might try to get together the correct data sources, they might run into a number of silos on where that data actually lives. And so they now need to bring in additional tools, other virtualization tools that add to the cost of just extracting insight from different landing zones for that data. So I find that to be a really important feature.
We hope it is. This was a lot of development time, and I think we agree that stretching the namespace is providing a significant amount of value.
Yeah.
And yeah, so this was a big project in the works, and we're happy that we've been able to release it.
Yeah, even one other piece I'll touch on, I'll be quiet and let you keep talking about the platform. But if you go back, I think it was one or two slides where you're talking a little bit about just the end user experience. One was the QoS, but before that, you were even talking about how you serve out the protocols. I think it's important to know. I just kind of want to level set with folks in the audience, and we'll probably have varying degrees of technical aptitude here, but just to call out like why this is important and different to around how they serve out the data to the end users is like a lot of times, I'm talking about it because I just made the reference to silos and why silos start to build over time because you have these different needs for storage and data. And it sometimes can be tough. In the past, it's been tough to kind of send all that data to one place. And if you were to look at maybe how a traditional parallel file system would have to provide like different protocol access to the system, they would have this concept of a gateway node or a protocol node type of experience. It's not something that feels like a traditional NAS. Now that becomes another element by which you have to study and figure out how to appease the performance requirements of just enterprise file capabilities. So even though I call out all these trends of the financial services space, diving into, the unknown with the algo arms race and the demand for like distributed compute. At the same time, there's still the traditional enterprise file needs aren't going away. Those aren't just like disappearing. And VAST is kind of coming in here and saying like, I can give you the best of both worlds, basically.
It's a fantastic point. When we have a strong relationship with Google, and when we talk to like the GCP team, they said the hardest adoption, the hardest the wall against adoption of moving just everything in the cloud is object has a different IO profile. You have to think differently. You can't be latency focused. You have to be more throughput focused. You can't just tell your system, oh, write object now and it works. And so having a something like a transition phase where if I'm moving my development into designing more around object, having that be incredibly clean and not feeling like I have to manage two systems or pay a penalty during that conversion, I think is a real big benefit for VAST. So at its core, VAST begs the question, if we can create this massive multi-petabyte, multi-hundred petabyte data storage platform, and we can run as fast as Scratch, but we can be scalable and affordable. There's layers of data reduction we didn't get into where we tend to do pretty well even on compressed data sets. We tend to have an industry-leading data reduction. If we can collapse all these tiers, that's always VAST's goal. If I can remove all these tiers, what do I eliminate? I eliminate silos of storage to manage. I eliminate time that you have to copy data in and out, right? If my Scratch is my archive, then I never have to pull my archive into a hot tier to compute against it. Everything is hot everywhere. So if we want to consolidate, we need to be able to deliver the ability to isolate data from a security standpoint. We do support full multi-tenancy, encryption, key encryption for different tenants, snapshots, and indestructible snaps for ransomware protection. That pooling we talked about before for performance isolation, if you need to be able to silo off different users' performance access and how much they can demand of it. So we feel like to be a consolidation platform, we need all these things. And then if we can consolidate and say, if we can make everything all flash, why not? And the industry is seeming to agree with us. We are replacing large scale, 50 plus petabyte archives that were typically relegated to slow spinning disk, typically like GPFS or Lustre. And we are consolidating all of the Scratch and the archive and saying, run as fast as you can.
Yeah. Something to note too is you brushed over really quickly, but I think that's another part to just highlight is, how are you bringing, the first thought is if I go and I attack all these different storage mediums from, backup to archival type use cases or workloads, and I'm attacking it with NVMe flash media, how is that cost effective at scale? And I think that VAST has really kind of changed a lot of customers' thinking in this space on what total cost of ownership looks like. Some of it has to do with data reduction, but also has to do with the fact that QLC media is approaching like near disk like pricing. And I think the other thing that people don't think about is there's a lot of soft costs associated with your infrastructure, namely the amount of energy and power consumed, especially if you own your data centers or you're renting space. So there's a lot of reasons to really ask yourself that question, like, well, am I actually saving myself much money by figuring out, brainstorming ways to tier all my storage, and at the same time, what are the soft costs associated with it? So I think that's a part that should be highlighted about what VAST brings to the table.
Yep, I agree. It's a really good point. And the lifetime of Flash is maybe one more to add into there. VAST grew up in Flash. We built our entire infrastructure around getting the longest life of Flash. So we expect these storage platforms to sit there for at least 10 years. So when you think about if you're looking to make investments and do this kind of on-premises infrastructure, not having to do a complete rebuy of the thing every 3 to 5 years, we think is also another massive benefit. No time spent migrating, rebuying all the hardware again. We are incredibly gentle with our flash. Some of our earliest customers that I have in this space that are at, many petabyte scale. If we look at like the SSD lifetime on these from 2019, I think they're at, I don't know, like 97 or 96%.
Wow.
So we expect, 10 years is the conservative timeline. We expect to keep the flash there and say replace it when it makes sense to you, when maybe the denser stuff is more economical to put it in there. But VAST is not going to look to rip out the storage and force these costly replacements in the standard life cycles.
Yeah. Yeah. One last point, and I'll let you. I'll stop interrupting your flow. But like,
You're great. You're great.
I like talking about, just because it's fun, specifically like the research side of things. But I think it's important, and I probably should have called out just like the growth of risks in like the cybersecurity space. And you kind of have this highlighted on the slide where here with where VAST fits into like the enterprise security conversation and protection. And I can't think of a single customer I talked to today that doesn't have recovery in mind. It's not like a if, it's like when. When will my time come that something happens, and like, do I already have a plan in place to recover quickly? I think I guess my mind was fixated on the fact that there's a lot of economic benefits to transitioning to all flash, but there's business impact to kind of think about on why traditional archive and backup, on spinning disk is no longer like the status quo, and is potentially not sufficient enough. And it has to do, I mean, can you comment at all to like how many conversations do you have today with customers that just revolve around, how quickly can I recover on your platform?
So to your point, while we absolutely want to play in the fastest environments in the world because of our unique data reduction, we can compete against the most data, the best software out there in the market today. This is a common discussion. It is, if I back up to VAST, I will see significant savings. Again, better than we go against traditional vendors like Data Domain, and we can outcompete even those. We have some very proprietary logic that goes to that. And if I can back up to VAST, but then have an actual ability to restore when you need to restore, I would expect faster than any production system can actually write. Our smallest systems you can restore at 40 gigabytes a second. So the restore times are incredibly fast. So people now look at us as a backup target that you could in a pinch restore to and run production on. Another functionality of that being that if I ever wanted to do these like synthetic, failovers, I want to fully bring up a complete virtual environment just to make sure that I can fail over, that traditionally required a whole nother copy of space somewhere. Because, if you're backing up to VAST, rehydrating and restoring to VAST really doesn't cause you the same penalties as traditional storage. So now you can actually do like full synthetic DR tests with only like an additional 5 or 10% extra capacity needed because of all the data reduction technology that's inside VAST. So we do enable this fast restore, but we also enable a lot of other functionality that comes along with it. Yeah.
Oh, yeah, well said.
Great. So let's, I think we highlighted on the GPUs. There's one part I wanted to cover quickly in here, but I think we said some of this, which feeding GPUs is important. If you're going to spend millions and millions of dollars on GPU, the last thing you want is them sitting there idle waiting for data from your storage. So having a massively parallel system underneath that can feed sequential data, small random data, again, because this is all flash and built for this type of parallelism, we are built for millions and millions of IOPS and hundreds of gigabytes to terabytes a second of throughput all in the same system. What we've done in addition to this is, because we are very, very heavily integrated with NVIDIA, is we've expanded, the functionality of our software. So NVIDIA has these cards. They're released in their latest, H100s. They're big boxes full of GPU, and they're called DPUs, Bluefield. They're these data processing units. They're these cards that sit inside every NVIDIA box. And because this is fundamentally the compute that's serving the data is fundamentally a container, we've actually qualified and can run these containers directly in these DPUs sitting on the host. So our VAST compute container that serves the data now becomes linearly one-to-one scalable for every one of these H100s that you purchase. And this allows us to drastically reduce the amount of actual compute on the side that's doing these post processes, and scale our compute inside the host themselves.
Yeah, so let me get this right. Just to clarify for the audience, like by moving some of the data services, footprint into this FPGA of sorts, into the DPU, which now is residing on the main computational vehicle for some of your modeling and stuff like that, you're able to then drastically reduce how much hardware you need to buy from VAST, or what are kind of the main effects that you get from that? Does it
Sure.
increase complexity? Does it become more simple?
I would say there's simplicity in design for sure. If you have to scale the amount of VAST compute to service traditionally hosts just making standard NFS connections over a network, as you grow these, we need to, in somewhat manner, make sure that we're scaling these. The second that we combine and we move the compute into the host, we are inherently getting the scale of VAST compute as you scale your GPU environment. So that kind of gives us this inherent scale. And then to your point on the power reduction, if I need just a handful of compute to handle post-processing that's not user IO driven, like data reduction and background replication and snapshots and all these other like kind of post processes that are normally shared, I can drastically reduce the amount of compute I need. And now if we were to look at like how much power to drive 100 gigs a second to feed GPUs in a rack, I can drastically reduce the amount of power in that rack to perform that.
Yeah, that's big. This is somewhat new, I take it, as a
Yes.
capability. And the reason why it's big is, again, this meeting isn't just about GPUs, but it's hard to not talk about like how it's having a profound impact on a lot of different verticals. And NVIDIA, I believe their kind of goal or their aim for like the best experience, so that you're not like wasting time on the GPUs, is they try to recommend having about at least a gig of read throughput per GPU. So as soon as you get, let's say, a dozen of these machines that have tons of GPUs in them, we're already breaking into the hundreds of gigs of read throughput requirements just for that. And so, yeah, calling out just like how by design you're bringing some of your software stack into that medium as a way to kind of simplify the deployment and still continue to get the performance. That's big. And I think it's important to talk about, because like the interest in this specific compute medium is not like just zeroed around large language models, ChatGPT. What we're seeing is a ton of interest for the traditional data intensive tasks in the capital market space and traditional machine learning. So, ETL processes, as well as, traditional ML tasks like random forest or logistic regression, things like that. We're seeing those workloads now shift and be drastically accelerated on the GPU space. So it's kind of like this desire, this hunger for this compute medium is, in my opinion, tightly coupled with some of the growing interest in VAST.
I 100% agree that certainly we are powering some of the largest GPU as a service hyperscalers that are then like all the big names that that are investing in GPU. A lot of them are using third party GPU as a service vendors, right? Like platform, like the GPU, the compute, the network. They offer that over, and then these really big companies bring over their data sets. They do their training, they do their inference. So the largest ones, like CoreWeave, is probably the biggest one, for example. They received a multi-billion-dollar investment from Microsoft, and they use VAST as their kind of core storage platform as they build out this like GPU as a service out to their customers. And they work with, again, the biggest customers in the world. They talk about the cost of storage staying online. I maybe briefly mentioned it, but we track it about 6 nines resiliency, and they say the cost of storage going down even for a minute in the cost of like losing training time and having to restart entire, multi-day or multi-week training platforms from scratch, because of an outage is so cost prohibitive that they need the most resilient platform out there. And that's one of the reasons that VAST was selected.
Awesome.
So let's get into the last place. So everything we talked about is about, attacking the storage market from a file object, massively parallel, massively scalable space. But VAST is we called ourselves a data platform, and the reason is that we're more than just delivering the standard storage services, maybe with like a lot of extra resiliency and scale and really winning in that market. But we want to focus on what we would call the structured data space. So if you're storing, how we see it is unstructured data, movies, videos, MP3 files. What are we doing with the massive amounts of trading data that can tend to collect in, petabytes and petabytes, and how are you querying that today? So VAST wants to bring this unstructured space, which we lived in, and now attack the structured space. And what we see in the market is a lot of ways to attack it, but it's built on the idea of a mutable object, right? A mutable object and spinning disk. So assume storage is slow. How can I, get away from storage as fast as I can? And the format that's kind of become the standard is Parquet. Parquet is really, nothing more than a columnar format that helps you reduce the amount of I/O you need to pull into the compute to answer questions. So if you could imagine, if I'm tracking Apple stock price, and for a given day, I might have, I don't know, a few 100,000 ticks. I might have a high of 100 and a low of 50, but maybe one tick in there was 100. If I were to do a query and say, show me every single time that Apple crossed 100, I have to suck in that entire file, because somewhere in there, there's at least one tick that says, yep, this crossed 100. So while this does allow you to kind of down select where you look for the data, you fundamentally, there's a lot of room, let's say, for improvement on how we can improve this. And the reason
highly volatile Apple stock there.
What's that? Yeah,
150.
Yeah, isn't I mean, Apple's what, like
I'm just messing with you.
Those numbers aren't real, yeah. So the problem is with these kind of let's say needle in the haystack or types of queries, you did this because if you think about spinning disk wants large chunks of sequential data. They don't want you to randomly try and find the small amounts. They're not going to be good at that. It's going to slow them down. So they said, why not read the entire 512 meg, 1 gig, right? Again, Parquet was built on a spinning disk format. So the interesting thing is VAST, when you think about us serving unstructured data, when we receive data, NFS S3, SMB, we immediately acknowledge it, protect it, and acknowledge it back to the host. Well, we've now built this tabular format underneath that can accept data SQL transactions instantaneously. So this is now, it's not just for this kind of batch processing. We have a transactionality here where we can be very quick and service large scale throughput-based queries all at the same time.
Like streaming data, like sequential streaming data.
Exactly.
Yeah, okay. Time series data.
Sorry, it took me a second to get there, right? So, and what we're doing is we're using the same structure that we use for file and objects. So when we receive these files and objects, we break them down. I don't care if they're gigabytes or terabytes in size. We break them down to these little 32K chunks and we scatter them all over the flash everywhere. And we do data reduction and a lot of other stuff. So when we think about this kind of tabular format that we're looking to build on VAST, we're basically saying, instead of having 512 meg to gigabyte as like a Parquet file, what if my size was 32K, 1/116,000th of a size, right? And I can still now add a little bit of metadata, just like an NFS file would have an owner, an ACL permission on it, right? An access time. This is just a little extra metadata I'm tying to that same type of functionality, only I'm putting in things like min, max, and count. And I can do kind of sorts. And because of this granularity, I can then do what we call these predicate pushdowns. So we've integrated with Trino, Spark, and Dremio. We look to them like a table structure. So you're not querying, objects over S3. Your query is pushing down the query itself to VAST and saying, hey, I don't want to find out where all the stocks are that crossed 100. VAST, you just give me the results of that. And so now VAST's filtered responses send back much less data, much faster. So this means much less time transferring the data back up to these compute nodes running the SQL query. Much less time they have, they don't have to throw away all of the junk data to get what they want, and they can get to the result faster. Right. So what does this really translate into? Here's two queries. Here is the idea of taking Parquet, putting it on fast S3, very, very fast storage, running this query. This is this public database. It's the taxi database. So we're searching for every time the tolls were above 100. And this took about 40 seconds. It returned 580 million rows because, again, Parquet is very chunky. So if one toll inside a single gig file had above 100, you're getting the whole file. The same exact Trino database with the data ingested into the VAST database, same query, returned 2,000 rows. And it returned 2,000 because we're only giving you the data you care about. So it's much less time you have to sort through, and you can get to your answer faster. So we went from 40 seconds to a little under 2 seconds, which is about a 22x increase in performance.
Yeah.
Same data, same query.
Yeah, that's game changing. I would, so some of the high level value from that is you're essentially not just getting significantly improved performance by shrinking the amount of data you're sending back to the query engines, but so then is it safe to say that most customers might be able to reclaim a lot of like estate in like how they architect for like how they run their queries, right? Because traditionally, like you said, they probably built out these large distributed query engines to kind of do tasks like this. Now you're saying that you might be able to drastically shrink that footprint now and still get, the same, if not better performance on a much smaller footprint.
Absolutely. It's either run your queries faster or run them at the same speed with much less compute.
Yeah, one of the two.
Where do you want to measure that, right? And this also offloads things like if you're dealing with Spark and you have like a Hive metastore, the Hive metastore there is to keep track of all this Parquet data. It becomes this whole other database that can become a bottleneck in all these queries. That all goes away because VAST is fundamentally tracking all the data. Because there's no Parquet, we are doing all the internal mapping, and we're leveraging all of the work we did to build a highly scalable, file system. So we're kind of just building it on the back of that. So this database, while it's been out for about a year, its foundation is built on what's been around since 2019. And when you talked about real time, these like formats like Iceberg can you're looking to ingest data into Iceberg table format, and it's being laid down as Parquet. Again, these are not meant to be streaming. This is 200 events a second. You have to do lots and lots of batches to be able to try and get anything close to what we would call real time. VAST can do natively 30,000 events a second. So when we start talking about this real time ingestion, this is why we say
Wow.
having that transactionality allows us to tackle the real time streaming as well as the very large batch, ETL curated data sets. So we expect to tackle both ends of it.
Wow. It's a big difference.
And I'll call it one nice little thing. So an eat our own dog food is we have something called the VAST catalog. It basically means that any data, any unstructured data you write over NFS, S3, SMB, we track all that data and create a separate table. Again, you can query it through the same Spark or Trino. We have an API, we have an SDK, but you can ask it any question. You can say, show me all the files owned by James that haven't been modified in 2 weeks that are greater than 50 gigs. And you could have billions of files or objects and you'll get a response within seconds. So you do on the unstructured space, as a nice little side benefit is we create this separate table that's VAST owned and updated. And we extend this out. So now you have an immediate understanding of your unstructured space as well as any, data you inject directly into your own database.
Yeah, this is good. Just as a quick time check, we've got just over 5 minutes left. And and I'll close this up here, but any kind of, well, was there just any other bits of content you want to talk to about the platform? But I wanted to also lay up another opportunity for you to talk about, maybe some um, customers, maybe without naming some names that you've come in and kind of changed their landscape by bringing Vast into the door.
Sure. I'll hit those two right now. So what we've covered, at a little bit of high level, but is the data stored in the database. Where Vast is going is the data engine. Not only do we want you to be able to stream events to Vast, we want to be the event engine driving that stream along with triggers and functions. So we really do want to understand and take on the entire pipeline to where a file dropped in creates a Vast trigger that then creates an event in a table space that is doing the event messaging that then kicks off a trigger that kicks off a remote function. We are thinking big long term, and you'll see a lot more announcements around this data engine second half of this year. And then to the other part on who we can reference, these are references that we can bring up. It's hard to find public references, but we've managed to wrangle a few, and I'm sure they would be happy to speak about VAST. But we certainly have a bunch more internally only. But yeah, we definitely have more than a few customers who've talked about us publicly and the benefits of VAST.
Yeah, I appreciate that. Yeah, I run into that a lot too, right? We don't always get big appetite for the public naming, just because it might cue others that like, hey, what are these folks doing? But generally speaking, I think it's just important to talk about this is a big trend, and you do run into a number of technology vendors out there, storage platforms that would love to say that they can do all these things. And what happens is, like, well, how do I expand my addressable market? Like, let's try to position our box for this. But VAST, I think, really is sitting in a unique space where it does the things that it says really well, right? You're designing specifically for these types of workloads, and then in doing so, you have customers that are discovering new ways that your platform is like changing the dynamic of like the IT storage estate. So yeah, I appreciate you sharing all that information about the VAST platform. I think, the last 5 minutes, I kind of wanted to call out a few things. One, there's going to be a survey that's sent out to everyone after this. And I don't know if you could progress the slides. Is there a piece that talks about, I don't think we have this on the slide where you guys will get an email. Yeah, we'll wrap it on the thank you slide. I didn't know if we had like a sample snapshot of it. I want to thank everybody for attending, for listening in. Hopefully this was valuable, give you guys a little bit of insight as to why CDW thinks VAST is a really compelling player here, not just as a storage manufacturer, as a storage vendor, but as an actual data platform for a number of different use cases in the capital markets, quantitative finance space. Again, I'm with CDW, and I just wanted to call out, if you have any interest in having a follow-up conversation, we'll be sending the survey out, but feel free to reach out to your account manager and set up a call with myself. I can have an agnostic conversation with you about what I'm talking with lots of other customers in the space. Again, CDW, we're a big company. We do a lot in the tech space, and you may know us as a VAR or potentially a service provider for you. But one of the big things I want to highlight is, what's unique about CDW is we have a specific verticalized category, sales category, just focused on financial services. So I think that sets us apart, right? But we bring a level of domain expertise and a number of years working with customers in your space, understanding the challenges you run into, not just technical challenges, but business challenges that your companies face, and encourage everyone to kind of connect with your account managers to schedule a follow-up call, or if you saw any of this to be interesting. Any last thoughts, James?
I personally worked with CW. You're a great company. Like you said, you come with a lot of resources. You've been great to work with. Some of our biggest deals have been our biggest wins together have been with CDW. So I would just reiterate that strong reaching out to CDW. They have a very wide range of a massive breadth of information across. Obviously, Anthony here has his focus, but I don't think there's a specialty you would say that CDW doesn't cover. So
Yeah, absolutely. Awesome. Well, I think that puts us right on time with like 2 minutes back. I think we had some good content. Thanks so much for co-hosting this with me, James.
thank you. This was great.